Students, till now we have learned what are rational numbers, how to find the additive inverse, how to find the multiplicative inverse of rational numbers, and how to find rational numbers between two given rational numbers. Now we'll continue this topic by irrational numbers. Let's discuss what are irrational numbers. In simple words, if I'll say the numbers which cannot be written in the form of P over Q, we can say they are all irrational numbers. Other way we can say a number which when expressed in decimal form is expressible as non-terminating, means the division is not complete, and non-repeating decimals, they are irrational numbers like square root of 2. Another example is 0.101011100 and so on. So these are irrational numbers. Let us discuss few questions which are in exercise 1C. First question is, classify the rational and irrational numbers from the following numbers. I'm just taking few examples from first question, few parts. First part is 5. 5 is a rational number. Okay. Under root 3, that means when you find square root of 3 using long division method, we found approximate value that is 1.732 and so on. So the number division is non-terminating. This number will be irrational number. Similarly, if I'll say minus square root of 5, if I try to find the square root of this number, okay, again this number will be come out to be non-terminating decimal. That means division will go on. Let's take one example here. Cube root of 8. Cube root of 8 can be written as, when I'm writing 2, 3 times. Now triplet is there. This is 2. So this number will be a rational number. Now in this part 0.20220 and so on. Again the decimal number is non-repeating, okay, and non-terminating. We'll say this number will be irrational number. Now question number 2. I have to find whether these are rational or irrational numbers. So I'm just taking few examples here. Square root of 25. Square root of 25 means 5 into 5, which means 5. So of course this is a rational number. 2.4 bar. Now if we have discussed earlier this type of questions, that means 2.444 so on. So this number, no doubt, this number is non-terminating, but the number, the digit which is repeating, that is same. So we can always convert this type of number in the form of P over Q as discussed earlier. So both of these examples are the examples of rational numbers. Question number 4. Write down the values of, okay, here a few examples are given. This is part 5. 3 plus 2 root 5 whole square. So I'm using identity a plus b whole square, 3 square, that is a square, plus 2ab plus b square. So we are using identity a plus b whole square, which is equals to a square plus 2ab plus b square. And when I simplify, I get 9 plus 12 root 5 plus 20, which is equals to 29 plus 12 root 5. So this is how I can write down the value of given number. 7th part. 3 upon 2 root 2 whole square. Now here I can say 3 upon 2 root 2 into 3 upon 2 root 2. That is multiplying twice. So numerator will be multiplied by numerator. Like this we get 9 upon 4 into 2. That is 9 upon 8. Let's discuss one more example. Part 8. 5 minus 6 root 3 whole square. Identity a minus b whole square, which is equals to a square minus 2ab plus b square. So here a is 5, that is 5 square minus 2 into 5 into 6 root 3 plus minus of 6 root 3. Obviously it will be square, it will be 108. 6 root 3, 36 into 3. Okay, this will be 25 and minus 60 root 3. When I simplify, I get 133 minus 60 root 3. Next question, question number 6. I need to show that following are irrational. I just need to show them. Okay, right now we are not to prove, we just need to show it. First part is 2 plus root 5 whole square. I'll use identity a plus b whole square. A square plus 2ab plus b square. That becomes 4 plus 4 root 5 plus 5. 9 plus 4 root 5. Now this is rational number. And because root 5 is there, this makes this number irrational. And sum of rational and irrational will become irrational. Therefore, I can say this number, square of this number will be an irrational number. Third part, under root 5 plus under root 3 whole square. Again using same identity, when I simplify, I get 8 plus 2 root 15, which shows sum of rational and irrational number. It gives an irrational number. Question number 7. In previous question number 6, I just need to show, and here I need to prove that under root 5 is an irrational number. Okay, solution is, I will prove this by contradiction. If I need to prove this number to be irrational number, I will let that root 5 is a rational number. By contradiction, I'll be proving it. That is, if it is a rational number, I can write this number as p over q, which is equals to root 5, where q is non-zero, denominator has to be non-zero, p and q are integers, and HCF of p and q should be 1. Only then I can say this is a rational number. Okay, for further proving, I have named this as equation number 1. Now squaring both sides. First of all, I will take q to the other side. This will become p is equals to 5q. When I square, I get p square is equals to root 5 square, root 5q square. And hence it will become p square is equals to 5q square. I named it as equation number 2. Next, now because root p square can be written as root 5q square, I can say p square is divisible by 5. If p square is divisible by 5, then I can say p is divisible by 5. That is, because p is divisible by 5, I can write p is equals to 5 into a, where a is an integer. A is an integer here. Squaring both sides. I am squaring this equation. It will become p square is equals to 25a square. And I name it as equation number 3. Earlier, I know p square is equals to 5q square. And now I got p square is equals to 25a square. So from second and third, I got 5q square is equals to 25a square. Simplifying, I got q square is equals to 5a square. Now this equation again shows that q square is divisible by 5. If q square is divisible by 5, that means q will also be divisible by 5. Earlier I proved p is divisible by 5. Now I prove q is divisible by 5. That means HCF of p and q is 5. If HCF of p and q is 5, this is the contradiction. This leads to contradiction because I have already let that HCF of p and q should be 1. Hence, our supposition is wrong, and therefore root 5 is an irrational number. So this is how we will be proving irrational numbers. Now let us take one more example. This is question number 9. Prove that root 3 plus root 7 is an irrational number. Again, I'll move it the same way. I will let root 3 plus root 7 is a rational number. If this is a rational number, that means it can be written as p over q, which is equals to root 3 plus root 7. Now here q is non-zero, p and q are integers, and HCF of p and q should be 1. So these are the conditions. Now squaring both sides, p square upon q square is equals to root 3 plus root 7 whole square. I will be using identity here, a plus b whole square. When I simplify, I got this result. that is p square upon q square is equals to 10 plus 2 root 21. Now if you see the right hand side of this equation, 10 is rational number, 2 is rational of course, but root 21 is irrational number, and left hand side of this equation is rational again. Hence it leads to contradiction here, because sum of rational and irrational will be an irrational number, and left hand side is rational. This leads to contradiction, and hence we can say that root 3 plus root 7 will be an irrational number. Okay, now next is question number 12. I need to write down 3 irrational numbers between root 2 and root 7. Now root 2 is irrational number, root 7 is irrational number. If I'll say the numbers which are coming in between, they are root 3, root 5, root 6. Root 4, if I'll say, that will come out to be 2, which is rational number, so I cannot write 2 here. So root 3, root 5 and root 6 are 3 irrational numbers between root 2 and root 7. Okay, now let us discuss how to represent irrational number on the number line. I am discussing spiral method here. I want to represent root 5 on the number line. So kindly please be attentive. You will be constructing with the help of compass here, pencil and scale. Now first of all, we'll draw a number line here. Number line means this will be from minus infinity to plus infinity. I take this point A as 0. That means A, origin. This is origin here. That means starting point 0. And this B point as 2. That means distance between is A and B is 2 units. Okay, now all of us remember how to construct 90 degree. So at B point, I'll be constructing a 90 degree angle here. This is how we'll be constructing. Of course, we'll be constructing with the help of compass. And this, I'll cut it out, this as 1 unit. That means if we are taking out this as 2 centimeters, this will be 1 centimeter. And name this point as C. I will join A and C. I'll open my compass equal to A and C, keeping the compass, needle of the compass here. And then from this point, measuring this, I will draw an arc which will cut out this number line. Now wherever this number line will be cancelled out, I will name this point as D. So AD here, this will be root 5. So this is how I will be representing irrational number on the number line. Okay, let us discuss one more example, that is how to represent root 10 on the number line. Again the same way, I will draw a number line here from minus infinity to plus infinity. I'll take this point, let's say this is point A, origin, and another point B. This will be 2 units. That means A to B is 2 units. And if you want to take it as in centimeter, you can take it as 2 centimeter also. Okay, at B vertex, I'll construct a perpendicular. Okay, and then cut it out. Name this point as C. This is 1 unit, or you can say 1 centimeter, and join AC. Now this is 2 units. This is 1 unit. Using Pythagoras Theorem, if I remember, 2 square plus 1 square, that is equals to AC square. So this will be 4 plus 1 is equals to AC square, that is 5 is equals to AC square. As we have done in the previous construction, I can say AC is root 5. But I want to represent root 10. So what I do, I take C as starting point. At C, okay, just turning this a bit, I'll construct a perpendicular here. Okay, and again cut it out as 1 unit. And if you are taking it in centimeter, obviously this will be 1 centimeter. Name this point as D. Now join this. This will be 1 unit. And of course, the same way, when we solve it, what do we get? Root 5 square plus 1 square, that will be equal to AD square. So 5 plus 1 is AD square, or I can say this is 6 is equals to AD square, or root 6 is AD. That means this AD is nothing but root 6. Next step. Again, I'll take D as vertex because we are doing spiral method here. So I will be constructing one perpendicular using compass. Okay, and then cut it out 1 unit. Name this point as E and then join A and E. This is 1 unit, that means 1 centimeter, and this one is 6 under root 6. So again, using Pythagoras theorem, it will be AD square plus ED square, which will be equal to AE square. That means root 6 square plus 1 square is equals to, this will be AE square. 6 plus 1, AE square. So this will be 7 is equals to AE square, or I can say AE is root 7. So this is root 7 here. Again the same way, perpendicular, and here cut it out 1 unit. This point is F. Join A and F using again Pythagoras theorem. Now root 7 square plus 1 square, that will be equal to, this is a right angle triangle, FEA, or you can say AEF. That means AF square, which will be equal to 7 plus 1 AF square. 8 is equals to AF square, or root 8 is equals to AF. That means this will be nothing but root A. Now next step is constructing a perpendicular again. Again 1 unit, cut it out. Let this point be G. Now join A and G. This is a right angle triangle. Using Pythagoras theorem, it will be root 9. Again taking this as point G, constructing a perpendicular here. Cut it out 1 unit. Okay, name this point as H. Now you can join A and H here, 90 degree. Now the last triangle is in triangle AGH. Okay, using Pythagoras theorem, I can say AG square plus now GH square, that is equals to AH square. So this is root 9 square plus 1 square is equals to 8 square, or 9 plus 1 is 8 square, or I can say root 10 is equals to AH. So this is nothing but root 10. But I need to represent it on the number line. So what I will do, I will open my compass equal to AH, keeping the needle here, and then using this, I will just draw an arc which will intersect somewhere here on the number line extended part here, and this point from A to this point, it will be square root of 10 on the number line. Okay, now based on these questions from exercise 1C, question number 1, question number 2, then 3, question number 4, question number 5, question number 6, question number 8, question number 10, and question number 11. And for further discussion, if you have any doubt, we can discuss in our class. Thank you, students.